This is an instructional video on identifying linear and nonlinear functions. The word linear, as you can see from the word itself, means line. Particularly, it means a straight line. Nonlinear, exactly as it sounds, means not a straight line. What we're looking to find and what question we're trying to answer is, does the function have a constant rate of change? Meaning, does it go up or down the same amount each time? And while that doesn't make sense just yet, we'll work through it as we do a couple of examples. For equations, we need the equation to be in slope-intercept form. Meaning it has to be in the y equals mx plus b form. This is non-linear because it is not in slope-intercept form. Slope-intercept form has no exponents. You'll notice in the y equals mx plus b, there are no exponents written. There is an exponent 3 here with the variable, and so that is not linear. That is not in slope-intercept form. For the equation y equals 8.75x, again, for all equations, they need to be in slope-intercept form, which is the equation y equals mx plus b. This one is linear because it is in slope-intercept form. The y equals is in the beginning. 8.75x, is the mx. The plus b at the end would be a plus 0. Zeros are not important, that's why it's not written there. But each part of the equation is in the correct order, in the correct form. Again, all equations, including this one, y equals 10 over x, have to be in slope-intercept form. The y equals mx plus b. This one is non-linear because it is not in slope-intercept form. It does not follow the y equals mx plus b. The y equals is in the correct spot in the beginning, but the x is on the bottom of a fraction, and there is no fraction in the y equals mx plus b. If it was reversed, y equals x over 10 plus b, that would be linear. The x cannot be on top, or excuse me, on the bottom. The x cannot be on the bottom. We can simply tell by looking at this graph that this is non-linear because it is not a straight line. We can clearly see that this line curves, whereas a straight line would look something like this. That is a curved line, it is non-linear. We can tell that these points are in a straight line, and so this graph is linear. Because it is a straight line. Even though this graph is going in the opposite direction, it's going down, it is still a straight line going down. And so this one is linear. because it is a straight line. Now for tables, tables is where we're looking for a constant rate of change. So what we're going to do is we can look and see how much we are counting by each time. 3 plus 3 is going to give us 6. 6 plus 3 is going to give us 9. 9 plus 3 is going to give us 12. We do the same thing on the bottom. 12 to negative 3 is negative 15. We're going down 15. Negative 3 to negative 18 is negative 15. Negative 18 to negative 33 is negative 15. We take each of those and make it into a fraction. When we make it into a fraction, y over x. So we can take the first one. The first one, y, is negative 15 over x, which is a positive 3. Negative 15 divided by 3 is negative 5. We do that for each one. We want to see if it's the same. So for the second one, y over x, the y value on the bottom is a negative 15. The x value on top is a positive 3. Negative 15 divided by 3 is negative 5. And we do it with the last one as well, just to make sure that it is all the same. The y value on the bottom is a negative 15. The x value on the top is a positive 3. Negative 15 divided by 3 is a negative 5. All of them are the same, negative 5, negative 5, negative 5. So this is linear because it has a constant rate of change. It's changing that much each time. So again, we have another table. We're looking for a constant rate of change. So looking up here at the top, 5 plus 5 is going to give us 10. 10 plus 5 is going to give us 15. 15 plus 5 is going to give us 20. Across the bottom, 2 minus 1 is 1. 1 minus 1/3 is 2/3. And 2/3 minus 1/6 is 1/2. So again, we're going to set up our fraction. We're going to look at each version. So we're going to look at the first section here, y over x. The y value on the bottom is a negative 1. The x value on top is a positive 5. Negative 1 divided by 5 is a negative 1/5. Looking at the middle section here, y over x. The y value is a negative 1/3. The x value is a positive 5. Negative 1/3 divided by 5 is going to give you negative 1 over 15. The last column, again, we write it as a fraction, y over x. Y value on the bottom is negative 1/6. The x value on the top is a positive 5. Negative 1/6 divided by 5 is going to give you negative 1 over 30. These are all different. They are not constant. So this is nonlinear because it does not have a constant rate of change. They're all different answers. Again, another table, so we're looking for the constant rate of change. So going here, 0 plus 0.5 is going to give us 0.5. 0.5 plus 0.5 is going to give us 1. 1 plus 0.5 is going to give us 1.5. 1.5 plus 0.5 is going to give us 2. We're going up 0.5 on that side. 0 plus 7.2 is going to give us 7.2. 7.2 plus 3.5 is going to give us 10.7. 10.7 plus 0.8 is going to give us 11.5. And the last one, 12.2. To get to 12.2, we have to add 0.7. 11.5 plus 0.7 gives us 12.2. So again, when we write our fraction, we write it as y over x. So looking at the first one, in our table, if it's never listed, the x value is first, the y value is second. So our y value is a 7.2, our x value is a 0.5. 7.2 divided by 0.5 gives us 14.4. For the second section, again, y over x, we have 3.5 over 0.5. 3.5 divided by 0.5 is 7. Looking at the third section, y over x, we have 0.8 over 0.5. 0.8 divided by 0.5 is 1.6. And the last section down at the bottom, y over x, we have 0.7 over 0.5, which is going to give us 1.4. All of these numbers are different, 14.4, 7, 1.6, and 1.4. So this problem is non-linear because it does not have a constant rate of change.